How to distinguish linear, area, and volume scale factors. Imagine you have a tiny model of a building and a full-sized version. How do you tell how much bigger the real building is compared to the model? That's where scale factors come into play. They help us understand how shapes grow or shrink across different measurements. But not all scale factors are the same. Some relate to lengths, some to surface areas, and others to the total space inside. Knowing the difference makes solving geometry problems much easier. Let's start with linear scale factors. These are the simplest. They tell us how much the lengths of corresponding sides into similar shapes change. For example, if a small triangle has sides of 3 inches and a larger similar triangle has sides of 6 inches, the linear scale factor is 2. It's just the ratio of the lengths. Think of it as how much you stretch or shrink the shape in one dimension. This applies directly to measurements like height, width, or length. Next, we look at area scale factors. These relate to surface or face areas of shapes like rectangles, circles, or triangles. The key is that the area scale factor is the square of the linear scale factor. So, if the linear scale factor is 2, the area scale factor becomes 4. That means the surface area of the larger shape is 4 times bigger than the smaller one. For example, if you double the size of a square, its area increases by a factor of 4. Now, volume scale factors are about the space inside three-dimensional objects like cubes, cylinders, or spheres. The volume scale factor is the cube of the linear scale factor. So, if the linear scale factor is 3, the volume scale factor is 27. This means the larger shape holds 27 times the volume of the smaller one. Think of it as how much more stuff you can fit inside when you scale up a shape in 3 dimensions. To sum it up, if you know the linear scale factor, you can find the area scale factor by squaring it and the volume scale factor by cubing it. For example, if two similar cubes have a linear scale factor of 2, then their surface area scale factor is 4, and their volume scale factor is. This helps you quickly figure out how much bigger or smaller shapes are in different ways. Understanding these differences is super helpful when solving geometry problems. If you need to find the surface area of a scaled shape, remember to square the linear scale factor. For volume, cube it. It's a simple way to keep track of how shapes change across all 3 dimensions. Whether you're working with 2-dimensional shapes or 3-dimensional objects, knowing the right scale factor makes everything clearer and easier to solve.